All right, what's going on, everyone? Mr. D'Souza here. I'm back from marking period 2. I hope you all had a great weekend, and we're going to just continue. So the aim for today is what's more to learn about circles. We aren't done. So there's actually a lot more things that we can talk about with circles. We just kind of scratched the surface. So with that being said, let's move on. The learning objective for today is we will be able to determine and use the relationship of intersecting chords where the intersection point is not the center. Okay, so you can kind of see in this picture down here that these are two chords and their intersection point, which is right over here, is not the center of the circle. So we're going to derive the relationships between the lengths of those segments as well as the arcs they intersect. So for example, we have like this arc over here and this arc over here, or we can talk about the relationship between this arc and this arc. There's gonna be a lot of writing, so make sure you're copying down your notes, and which is a perfect segue as a reminder. So you should have watched the video that we posted this morning. There's a video that we created that's going to go over what you need to do Tuesdays and Thursdays. We're trying to make the work a little bit more manageable, but here's a quick summary. Tuesday, you got to watch the video. There's going to be one video a week now for the mini lesson, okay? You need to take notes, and what that means is you need to write down the aim, the learning objective, vocabulary, examples, etc. What Miss James did for us is she create an exemplar of what that looks like. So like a perfect example of today's lesson. So if you're confused as you're writing notes today, you want to look at what she did so that you can like mirror what she did. Okay. Also, with that being said, if you didn't write down the aim and learning objective, you should pause the video, go back and do that, right? Because that's one of the things that gets you to a 4. Remember to look at the rubric that we posted on Google Classroom, because that's going to tell you how to get those grades. In addition, the practice problems are posted today. Try them. However, on Thursday is when we're going to post the solutions video to those questions. So if you're struggling today trying to figure out how to do those questions, wait till Thursday, look at the video, fix and edit your work, and then submit it. In addition, on Thursday, you're going to get your exit slip, which is going to be graded as a quiz. And then lastly, you're going to get your homework, and everything will be due on Sunday, 11:59. Now, if you're like, hey, Mr. D'Souza, that's a lot of new information. I didn't know this. That means you did not watch the video that we posted this morning. So please go back to your Google Classroom, look at the stream, and there will be a very, very, very important video. I think it's like 10 minutes long of us going over this new way that we're doing this. Okay, so it's going to be a little bit less for you to do, but you're going to have a lot more time to do it. Okay, with that being said, let's kind of jump into it. All right, this is actually Dan or Mr. D'Souza from the future. I just want to remind you of one thing. So somewhere in this video, there is going to be a password that I'm going to give you. I will explain later what that is, but please be on the lookout that there's going to be a password somewhere hidden in this video that you're going to need to get a classwork grade. Okay, so just keep that in mind. Let's get on with the lesson. So the first thing that we're going to do, I know you see statements and reasons and you're probably like, OMG, what's going on? But before we get there, we want to derive a relationship that we see between the lengths of the segments of intersecting chords. So these are chords, right? The endpoints of these line segments are on the circumference of the circle. And what we mean is, I want to see if there's a relationship between like these segments. So these like little segments that I'm highlighting. So AE, CE, and so on and so forth. Can you predict the relationship between these line segments? I encourage you, pause the video and think about it for yourself. Some of you might think, well, they're not the same, right? They're clearly not the same length, so there must be something else. So we're going to use math that we have learned before to kind of derive or come up with a relationship between these line segments. So join me on this mathematical journey. And just remember, take notes. That picture should be drawn, and everything that I'm writing should be written on your paper. Okay. So first things first, something that's going to make this easier is if we connect D and A and C and B. You might be asking yourself, whoa, I see two triangles. And that's true. You do see two triangles, and that's going to be very important. So let's write a couple of things down. Just based on what we have in this picture, we know we have a circle O, and then we also have two triangles. We have triangles AED, and we also have triangles CEB. And that's going to be given. That's literally in the picture. So is there anything in the picture that we can definitely see? Yeah, so some of you might be saying, hey, there are vertical angles here. Yeah, so angle AED is congruent to angle BEC. Okay, and the reason that we can say that is because vertical angles are congruent. Okay, now this next part you might be saying to yourself is, well, what are we even trying to prove, right? We're doing statements and reasons, and I didn't tell you what we're trying to prove. Well, first thing we talked about before is we tried to make a prediction, and the prediction or something that I mentioned was, well, these lines are not congruent. And we're talking about two triangles. So if the lines or the sides are not congruent, then the triangles are not congruent. What else did we learn about triangles in terms of proving stuff? Yeah, that's right. Similarity, okay? So similarity in triangles, there are three things. There's AA, there's SSS, and SAS. Okay, those are the three things that we can use to prove two triangles are similar. And if you notice, we already have one angle in common. Now, we don't know anything about the sides, and the only things that we've been learning about circles are kind of like central angles and inscribed angles. So maybe the next step for us to think about is, are there any inscribed angles? So for example, this angle, I'm gonna do the best I can to outline it, is an inscribed angle. But check this out. This angle, DCB, is also an inscribed angle, but do you notice that my purple angle and my yellow angle, so like angle A and angle C, they both outline or intercept this arc? And what do we know about when two angles intercept the same arc? They're congruent. So we can say now that angle A is congruent to angle C. And the reason for that is, so I'm going to reread it because it's lagging so much I can't really write as neat as I can. So angles that intercept the same arc are always congruent. And we're done. We know that triangle AED is similar to triangle CEB, okay? And the reason for that is angle similarity. Now you might be asking yourself, Mr. D'Souza, why do we prove that these two triangles are similar? Who cares? Remember, we want to try to figure out a relationship between these line segments, right? And if we know that these two triangles are similar, what do you know about their corresponding parts, or rather their corresponding sides? They are proportional. So we can set up a proportion for both triangles. So AE is proportional to CE, and DE is proportional to BE, right? So this is proportional to this side's proportional to that side. I'm going to make it even easier. I know a lot of us are like, oh no, fractions. Well, there's something that we can do. We can manipulate this. We can actually cross multiply. So AE times BE, which is equal to CE times DF. So we actually just discovered a relationship. This relationship is about intersecting chords and segments. If two chords intersect within a circle, then the product of their partitioned segments of one chord equals the product of the partitioned segments in the other chord. Partitioned is a fancy word for kind of like a cut. Doesn't mean in half, it just means to cut, or to like to break into a piece. But let's use cut because that's a more basic word, I guess. So if two chords intersect, so this chord and this chord intersect, their cut pieces, if you multiply them together, it equals the other two cut pieces. So it's like the blue piece times the gray piece equals the yellow piece times the red piece. So we just derived, or we really discovered, that relationship. So let's do an example. So in circle M shown, chords G, H, and E, F intersect at K, such that EK is 5 and FK is 6. If GK equals 3, then which of the following is the length of GH? So I'm going to encourage you to do two things. Pause the video, write out the relationship between the parts of this circle. So we learned about, the partitioned chords, their product equal each other, and see if you can figure this out on your own. I'll wait. All right, so let's do this together. So the partition pieces is GK and HK. So we know GK times HK is equal to EK times FK. So let's just fill in the information that we know, right? And I know it's asking for GH, which is the whole line segment, but we're not there yet. The only thing that we learned is this relationship, and let's see if we can use this relationship to get there. So GK is 3. HK, we don't know, so I'm going to put a question mark. EK is 5, and FK is 6. 5 times 6 is 30. 3 times something is 30, so divide by 3 on both sides. And that something is 10. So that means my answer is 10, right? Nah. Because remember, this question mark was HK. HK equals 10. That's only this piece. I want GH. I want the entire thing. So if GK is 3 and the rest is 10, 3 plus 10 is 13. And that's your final answer. Okay, so if you got it wrong, that's okay. But I encourage you to do it again on your own. All we did was we identified a relationship that we saw in the picture, filled in what we knew, and from there, we figured out how we could get to our answer. Okay, all of what we've been doing in the past, really forever for now, is we're given something in geometry. You write down the relationships that you see in the picture. You try to use the information that they give you with those relationships, and then you figure out how you can get to your answer. Okay? So we're actually going to take a brief pause. So for a classwork grade today, in addition to the stuff that we've already been doing, the exit slips, homework, blah, 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 we're going to be hiding like a password within all of our lessons. So what's going to happen is in the directions for your mini lesson video, we're going to have a link that says the following. So you don't have to retype it. You can just click on the link. You're going to fill out basic information, your name, your class, who teaches you. So for example, if you have me as an official teacher, like if we were back in BTech and you went to my class, I'm your official teacher with Miss James. For example, if we were back at BTech, Miss James and myself, if we were your teacher, you're going to choose us as your official teacher. If you went to Miss Fu, she's your official teacher. Okay, that's super important. But anyways, you're going to click the link, you're going to fill out the basic information, and each time that we have a mini lesson video, there's going to be a password box. Today's password is going to be hashtag MP1. Okay? If you type that in exactly like that, you will get a free 100 for this little mini assignment. If you don't write it that way, you do not get the credit, okay? So in the future, there are going to be times where you will find the password somewhere inside the lesson. It's not always going to be in the middle. It might be in the beginning. It might be at the end. Who knows? And you're going to use that to get a free classwork grade. Okay, so now we're going to learn the second thing for today. And I'm going to do it a little bit more college-like. So in college, a lot of the times what they do in math classes is we'll give you the information, like we'll give you the fact. And really in math, we don't really care about well, depends on what kind of math, but usually we don't care about like the answer. We care about like why that's the answer or why something works. So I'm going to give you the fact right now, and then I'm going to show you why it works. Okay, there's gonna be a lot of writing, so make sure that you're taking your notes. And I encourage you, pause the video if you don't understand something and try to move back to see if you can understand it the second time. Because it's gonna take a little bit of time for you to see where I'm getting all this information from, because this is a little bit more complicated than what we've been doing, okay? Well, the fact is this. It's a theorem, and the theorem states that the angle formed by intersecting chords is given by 1/2 the sum of the measure of the intercepted arcs, okay? And really what that is saying is, hey, if I want this angle x, I want you to notice that because these are vertical angles, and you'll notice that this is the same picture as we used in the beginning of the lesson, if you notice that this angle is also x because these are vertical angles. And do you notice that the arcs that are opposite of the angle is this one and this one, okay? There is a mathematical relationship between the angles of the intersecting chords and the arcs. So if I wanted to relate angle x to the arcs of the circle, the formula would be you add the arcs, so AD plus CB, divide it by 2, and you get the angle. Okay? Similarly, let's pretend I wanted this angle. So this is angle Y, let's pretend. That means this is angle Y. And their intercepted arc is AC and DB. So if I wanted to relate those angles with the red arcs, it would be AC plus DB, so the red arcs divided by 2, and that will equal the angle that's facing them. But to make it a little bit more simple, we're just going to talk about angle X. Okay? Now, you may want to pause the video and ask yourself, where did this formula come from? Can you figure out how to get this formula? Now, some of you might be thinking, oh, well, the arcs are opposite the angles, so it might have something to do with that. But let me push you further. Where did the 2 come from? Math isn't magic. There are reasons why things work. And I think if you can follow along with what I'm about to do, it's going to kind of blow your mind where like certain facts come from. Okay, so let's jump into it. Again, I encourage you to pause the video if you get confused, because there's going to be a lot of information that we're going to be talking about. All right, so to be able to kind of prove why this works, we got to list some facts. And the first things that we got to do is do what we did in the other pictures. We need to make triangles. So I'm going to make some triangles, and I'm going to tell you right now, this has nothing to do with similar triangles. At least the way that I'm doing it has nothing to do with similar triangles, so don't worry about that. I'm going to pick green because that's my favorite color. And now I just want to list some facts. So number 1, I want to label my triangle. I'm going to label this angle Y and this angle Z, just so that I don't have to keep saying like oh, angle DAE and angle AD, whatever. So when I say angle Y, that's this angle D, that's that angle, and this is angle X. In addition, I want to show you a couple of things. Angle Y, right? I can outline that. And let's say I wanted to write a relationship between angle Y and its intercepted arc. Angle Y is an inscribed angle, so the angle is half the arc, right? But another way we can say that is if you double the angle, it gives you the arc. So one relationship that we can write down is the following, that the measure of arc BD is equal to 2 times angle Y. Because remember, if you double the angle, it gives you the arc. Let's look at angle Z. If I outline angle Z, I can also talk about this arc. So the measure of arc AC is double of Z. Okay, that's just inscribed angles, right? We learned that the angle is half the measure of the arc, right? So if you cut the arc in half, you get the angle, but the opposite way is if you double the angle, you get the arc. Okay, so that's one relationship that we want to talk about. Another relationship, and I just want to rewrite my angles. So remember, this was also X. We labeled this angle as Y and this angle as Z. This one you can definitely come up with. What do we know about X, Y, and Z? Yeah, they add up to 180 degrees. That's the triangle sum theorem. So angle X, I'm just going to write X, Y, and Z. It's just a little bit easier for us to see instead of like angle X, angle Y. So X plus Y plus, Z is 180 degrees. And I'm going to do one thing that you're going to be like, Mr. D'Souza, why are you doing this? Because it's going to work and it's going to make our stuff a lot easier to do later. Anyways, so one thing I'm going to do is I'm going to subtract X on both sides of this equation. And you're going to get the following. Y plus Z equals 180 minus X. Okay? I'm going to box this. And I'm just going to circle this. I'm going to circle this. And I'm going to circle this. These three things are facts that we are going to use, that I'm going to use to show you why that this formula works. Okay? There's actually one more fact, and that is the following. That arc AD plus arc BC plus arc BD plus arc AC, right? Those are all the arcs. So AD, AC, CB, DB. A full circle is 360 degrees. So when you add up the measure of all these arcs, it has to be 360 degrees. And actually, we're going to be using this equation and the information that I circled in blue to essentially write the formula. But you might ask yourself, but Mr. D'Souza, the original theorem has the value X. Where does X come from? There's no X here. Just you wait. All right, so let's see if we can use any of the information on the left-hand side. Well, it says here that arc BD is 2y and arc AC is 2z. So I'm going to substitute those values here. So now we have that AD, BC, but now I can replace BD with 2y and AC with 2z. And that equals 360 degrees. All right, Mr. D'Souza, so what? What can we do now? Well, do you see now we have y and z? So I used these two facts. But you see how we have y and z? Now do you see why I wrote this as y plus z? It kind of looks like what we see. However, I want you to think back to algebra. What else could we do? If I wanted to get yz, like y plus z, literally looking like that, what could I do here? Well, yeah, I could factor out a 2. So if I factor out a 2, I'm left with y plus z equals 360 degrees. I'm getting tired of writing AD plus BC, but it's important because if you notice, our equation, our formula has AD plus BC. Very exciting. So we have 2 times, but what's y plus z? Well, it's 180 minus x, right? It's an equivalent relationship. So 180 minus x is 360 degrees. And then we can use algebra and we can distribute out the 2. And we're left with 360 minus 2x equals 360. I'm going to bring down my AD plus BC. I hope you see the AD and BC are going to stay here forever. Now, I want you to see something. Do you see now that we have an x in our equation? Why don't we get x by itself and see what happens? So what I'm going to do is I'm going to subtract 360 on both sides. I'm going to scroll down a little bit, and I'm left with AD plus BC minus 2x is 360 minus 360 is 0. But I want to get x by itself, so I'm going to bring the 2x to the other side. So the inverse operation of minus 2x is plus 2x. And I'm left with AD plus BC equals 2x. But if I want to get x by itself, what's the inverse of multiplying by 2? Yeah, dividing by 2. So I'm left with AD plus BC divided by 2 equals x. And this actually gives us the formula that we got in the beginning, that if you take the arcs that are opposite the angle that you're looking for, divided by 2, you'll get the angle. Okay, and to simplify it, here we go. On the top, I rewrote the formula, and I put the picture there, but I want to tell you something, that it's not about memorizing the formula, it's understanding what the formula does. Because you'll see in the next example, it doesn't use A, B, C, and D. You have to remember that if you're talking about arcs and angles of intersecting chords, you can set up a relationship. So remember that the arcs that are opposite the angle that you're looking for, or the angle that you're using, are the arcs that you're going to use. So with that in mind, I want you to try this example on your own. I encourage you, pause the video, write the relationship based on this picture now, and try to answer it. All right, let's do it. So it says in circle K, diameter TW, that's going to be important, intersects chord RS at X, such that the measure of arc SW is 38 degrees and the measure of arc WR is 98 degrees. Which of the following represents the measure of angle WXS? So let's fill in some information. We are looking for WXS, which is this angle. Okay, so I'm going to put a question mark. Okay, but this angle is congruent to this angle, right? Which means we need to look at the arcs that are opposite those angles. So that's RT and WS. So before I even fill in more information, I'm going to write out my formula so that I know what I'm looking for. So it's going to be RT plus WS divided by 2 equals the angle that I'm looking for, which is WXS. So angle WXS. Well, let's fill in some information that we have. So SW, this arc is 38 degrees. But they're giving us that this arc, WR, is 98. I don't want that arc, right? I'm not looking for that arc at all. I'm looking for RT. Well, we got to look at the information that they give us in the question. It says that TW, this line, is a diameter, which means WR plus RT is half of a circle, which is 180. So if I'm looking for RT, we're going to do 180 minus 98, right? So the 180 is the whole thing. Taking away 98 gives us the remaining piece, which is 82. So this piece is 82. Now we have enough information to solve this problem. RT, we found out, is 82. WS is 38. If you divide that by 2, you're going to get WXS, right? You're going to get those angles in the middle. So I'm going to do it on my calculator on my phone. 82 plus 38, which is 120. Actually, I'll write out the whole thing. It's 120 divided by 2. You divide that by 2, you're going to get 60 degrees, which is this one. Okay? So just a quick summary. We learned 2 things today. In general, we learned about intersecting chords. More specifically, we learned about a relationship between the segments, right? The partitioned parts of the segments. When you multiply them, they equal each other. So for example, AE times BE equals DE times CE. Okay. And then lastly, we also learned about intersecting chords in regards to the angles that they create and the arcs. So if you're looking for, let's say, angle X, right? These two are the same angle. They're opposite of this arc and this arc. So in this case, we could add up those 2 arcs and divide by 2 to get us those angles. Okay. And then lastly, because this is the first video of the new marking period, I just want to go over those reminders again. If you reached up to this point, that means you also figured out what the password was. But also that means you watched the videos and hopefully you took notes. I'm gonna be very honest, this lesson, there were a lot of notes. Please look at what Miss James posted so that you can see what perfect notes look like, okay? In addition, today, you should try the practice problems. But if you're still a little confused, there's a couple of things. Make sure you go to office hours. You can email myself, Miss James, Miss Fu, Google chat us. You can also just wait till Thursday to check out the solutions video. Remember, it's not just the solutions. We literally go over the questions in detail. In addition, remember on Thursday, there's going to be an exit slip that's going to be graded. And lastly, you're going to get homework that's going to be all due on Sunday by 11:59. Remember, there's no late work accepted because we're giving you multiple days to do it. Okay? And if you have not already, please watch the video that we posted in the morning that goes over all the new stuff, as well as reminding you how to go on Google Classroom, how to find the assignments, where you're going to find things. Please watch that. All right. I hope everyone has a great rest of your day. And we'll talk to you in the next video.